Hello students, welcome to today's physics class. The topic for today's physics class is machines. Machines. What is a machine? A machine is a tool or a device in which effort applied at one end can be used to overcome load at the other end. An example of a machine is a simple pulley. On the board here we have a simple pulley. Do you see what is happening here? A student at one end applies effort. As this student pulls this rope that is hung around this pulley, this student overcomes the load attached to the rope at the other end. Do you understand? In the topic machines, there are things we can calculate. One of them is efficiency. There's a problem on the board. There's a problem on the board where we are asked to calculate the work done by a student. The problem is this: the efficiency of a machine is 60%. Calculate the work done by the student in using this machine to raise a load of 150 kg through a vertical distance of 2 meters, of 2.5 meters. And you are given that acceleration due to gravity is equal to 10 meters per second squared. We are going to use this formula. Efficiency is equal to work output over work input multiplied by 100%. The work output is the work done by the machine in raising this load from the ground to this distance, 2.5 meters. That's the work done by the machine, the work output. Then work input is the work done on the machine, the work done by the student. I hope you understand that here it is the student that is overcoming the load. The work that the student does is the work input, the work that the student puts into the machine. Do you understand? And the diagram here has illustrated the problem we're going to solve. We're asked to calculate the work done by the student, which is the work input. Remember, we are given the efficiency at 60%. So let's go ahead using this formula here. Efficiency is 60% is equal to the work output. How do we get the work output? Remember, the formula for work is force times distance. Force times distance. And here we're working on a load, 150 kg. The force here is a downward force. That is the weight of the force. Do you remember the formula for weight of a body? The formula is mg, that is mass times acceleration due to gravity. That is the work. So here I'm going to, that's the weight. This is the formula for weight. W is equal to mass times acceleration due to gravity. And then the work is the weight, that's the force, times distance. So here I'm going to write 150, which is the mass, times 10 times the distance, 2.5 meters, over the work input, that is work done by the students multiplied by 100%. Do you understand? 60% is efficiency. The mass of the body is 150 kilograms. Acceleration due to gravity is 10. And then the distance is 2.5 meters. We do not know the work done by the student. That's what we're going to calculate now. Okay. Do you remember cross multiplication? Work done by the student is going to come up, and then this 60 comes down here. So we have work done by the student is going to be equal to the numerator here, 150 multiplied by 10 multiplied by 2.5 multiplied by 100 all over, you bring this 60 down, all over this. Do you understand? Okay, this 0 goes with this 0. Can 3 go here? How many times? 2. Can 3 go into 15? How many times? 5 times. You write the 5 here. Then you cancel this 0 and bring it up here. Any problem so far? What else can go? Can 2 go here? How many times? 1. Can 2 go into 5? How many times? 2. Remember what? Remember 1. Remember that 1 is in base 10. So we'll have, cancel this. You have 5 here. Do you understand? Any problem so far? Now let's move on. We have 25 here, multiplied by 10, multiplied by 2.5. 10 multiplies 2.5. What does it give us? 25. 25 times 25. Do you remember the squares when you were in JS2? Okay. We still have another 10 here, multiplied by 10. 25 times 10 times 2.5 times 10. Okay, let's take this. 10 times this is 25. So we have 25 times 25. 25 times 25 times 10. When you were in JSS2, you studied squares of numbers. Do you remember? Were you able to do 25 times 25? What did you get then? It's 625. 625. And now you're multiplying by 10 again. So you have 6250 joules. That is the amount of work done by the student in raising that load through that distance, 2.5 meters. Do you have any question? If you have any question, you can drop the question in the comment section. We'll talk about it in our subsequent classes. Thank you.